Hi everyone, sorry for the little bit of a late start here. We're having a few technical issues, but we should be back and good, and everyone can hopefully hear and see right now. I'll give everyone just a couple of moments to log on and join us. If you want to, as you're logging on, just give us a shout out in the chat. Let us know where you're joining from so we can see where everybody is. That would be wonderful. Oh, nice. Welcome, Tina from the UK. Tucson, Colorado, New York. Isabel. Hi, Isabel. One of my friends from the UK. North Carolina, California. Wow, we've got people all over the world. Fantastic. You can still see that people are still joining, so we'll give it just maybe one more minute before we start. Thanks, everyone, for your patience. Ohio. So good to know so many people care about fish. This is great. All right, so there we go, 2:35. Let's make a start and anybody else can join us as we go along. So thank you all for joining us this afternoon, sorry. As I say, if you want to use the chat function during this webinar, then we'll, with any questions or any comments, and please feel free. If you have any specific questions that you're interested in asking the panelists, please could you put those in the Q&A function rather than the chat so they don't get lost. And then at the end, if there's any questions which we haven't answered, we can pick those up and get back to you on them. So to introduce myself, my name is Liz Tyson. I am Programs Director from Born Free USA. Those of you unfamiliar with our work, Born Free USA is focused on keeping wildlife in the wild, and that means both protecting wild animals in their natural homes as well as campaigning to end their exploitation and captivity, which is exactly what we're here to talk about today. So our newest report, Oceans Away from Home, explores the fascinating world of fish and the ways in which they're exploited for our entertainment. We really wanted to cover this topic because we just feel that fish are so overlooked as animals, partly because they're so different to us. And I hope that this webinar with our fantastic panel of speakers is going to help to shed light on the importance of fish, both as species and as individual beings with complex capacities to think, feel, and suffer. So I want to tell you a little bit about our panelists before we dive into this. We're starting out with Devon Shoei. She is our campaigns associate for Born Free USA. She began working with Born Free USA as a primate caregiver in 2015. And after her first stint with us, she took a break to complete her master's in primate conservation in Oxford in the United Kingdom. After achieving her MSc and traveling parts of Southeast Asia and Europe, she returned to Born Free USA and in 2021 took up her role as campaigns associate. Since that time, she's been responsible for leading on multiple important projects. A lot of our research that comes out will have been authored by Devon. And she's responsible for the research involved in our most recent report, Oceans Away from Home, which will be the subject of her talk today. After Devon, we'll have Jack Wharton join us. Jack is a fish welfare and conservation expert who joined the Forth Rivers Trust in Scotland in 2018 and is the Trust's eel specialist, currently leading on 2 European eel study projects. Jack is an experienced field surveyor and has provided ecological clerk of work services on a number of projects, including the River Life Barrier Easement Plan, as well as assisting with fish rescues and habitat surveys. Jack is currently working on his PhD at the University of Hull in the United Kingdom. And today, Jack's going to be speaking to us about fish welfare and conservation. And last but not least, we're joined by David Neal, who is Animal Welfare Director of the Animals Asia Foundation. He's based in the UK. Dave's worked for Animals Asia since 2002 and travels extensively to head up Animals Asia's campaign to improve animal welfare in zoos and safari parks, particularly in China. He also works to increase general veterinary and animal welfare standards and promote animal welfare education in schools and university. And today, Dave's going to be exploring the fascinating subject of fish sentience and cognition. So hopefully we're going to come out of this better informed about our fish brethren and find out ways that we can help them. So without further ado, I'm going to hand over to Devon right now, and we're going to save questions till the end. So as I say, please feel free to put your questions into the Q&A function, and we will get to as many as we can at the end of this talk. All right, thank you so much, Devon, if you'd like to join us now.
Hey everyone, thanks so much for the introduction, Liz. I'm really excited to be talking about fish today. As many of you know, fish have long been very neglected from the larger animal welfare and conservation discussion. So it feels really good to sort of put the spotlight on fish today. I think it's long been deserved. So I'm excited to talk about fish today. So I will be talking about our most recent report that we came out with called Oceans Away from Home, the Suffering of Fish in Captivity. Oh, sorry, there's a bit of a lag. So for the key report findings that we discovered through this report, there is a universal research bias that really neglects fish, which causes a massive knowledge deficit in their welfare, biology, and their conservation status. Also, the unregulated and unethical taking of fish from the wild to supply the ornamental fish trade is a very prevalent problem that needs to be addressed. The inability of zoos to educate visitors, safeguard fish welfare, and help conservation in the wild is also a huge problem. And then the failure of the United States legislation currently in place to adequately protect fish from abuse, cruelty, or neglect in captivity is also an issue. So we'll go more into all of those points in more detail later, but the first one I'd like to talk more about is this global research bias that neglects fish. So in a literature review of BIAZA facilities, that it indicated that there were projects that most certainly they focused on primates most often, and then second to that, carnivores, hoofstock, birds, reptiles, amphibians, and least frequently, fish. So the same bias holds true for North American AZA facilities. So it turns out that 2/3 of all AZA member research has focused on mammals. And for the remaining research, just 12% to birds, 8% to reptiles, and then only 5% to fish. So to provide a bit more context about the private trade of fish and why it's so problematic, fish are some of the most popular animals kept in captivity despite this real lack of knowledge about them, about their biology, about their conservation. So to kind of give you an idea of this, in 2023, 139.3 million freshwater fish were reported to be kept as pets, which is more numerous than the dogs and the cats kept in the United States. So also, while 95% of freshwater fish are bred in captivity, up to 99% of marine or saltwater fish in the aquarium trade are taken from the wild. So that causes a lot of wild population depletion that's really not being monitored at this point in time. Globally, it's estimated that more than 1 billion ornamental fish, both freshwater and marine, from some 5,400 species are traded annually for the aquarium industry. And in this trade, mortality rates from stress, injury, disease, or mistreatment during transport for the private trade have been documented to exceed 80%, which is obviously extremely high, extremely damaging to these animals. And estimates of fish imported and exported by zoos and aquariums remain almost impossible to quantify. And this is largely because fish are not monitored in the same way that a lot of mammals are monitored in zoos and aquariums. So for example, for mammals like giraffes, elephants, primates, they have what are called stud books, which monitor major life events in individual animals' lives. So that will be a birth, a death, or a transfer between facilities. So for fish, these simply just don't exist. So for the most part, fish are really not treated like individual animals within the zoo and aquarium industries. So to give a bit of context about welfare in general and welfare as it pertains to fish, the absence of fish in scientific literature suggests that knowledge pertaining to their care and their species-specific needs may also be lacking. So positive welfare protects animals from experiencing things like boredom, helplessness, emotional distress, which can result in adverse health conditions, including physical injury, disease, developmental delays, metabolic issues, and mental illness when endured long-term. And interestingly, the subcortical neural networks in fish are neurochemically the same as what we see in terrestrial mammals we would traditionally associate with complex cognitive function, emotion, and importantly, pain. So what a fish's lived individual experience is actually a lot more similar to other animals, that we could maybe be better at, perceiving their emotional expressions in a better way than what we can see in fish. Their lived experiences are actually a lot more similar to other animals, and then also our own than we previously have thought. So fish regularly participate in complex behaviors that we do typically associate more with other more, quote, social animals. They do a lot of the same things. So like recognizing others as individuals, exhibiting paternal care, engaging in pro-social behaviors like grooming each other, and constructing complicated social groups are all things that fish do on a regular basis in the wild. Some cichlid species form monogamous pairs and have helpers, which altogether construct a social group who participate in defending territory and offspring. In zebrafish, even just visual contact with a conspecific can be used to reinforce behavior in an associative learning task. Mozambique tilapia will push against a door to access social partners. And then similarly, goldfish will swim against a current to access plants. So we can see how certain species of fish will actually expend more energy and do things that are more difficult to achieve something like a social partner, like plants, like natural elements that are usually present in their wild habitat to improve their well-being. So just some more examples that exemplify how complex certain fish species behavior is in the wild. So pearly razorfish, which are a good example of a lot of species kept by aquariums as they're sedentary species, they're coastal dwelling. They reach 8 inches in length typically. They've demonstrated a circular home range on the smaller side of fish species, which encompasses a radius of 476 feet, which is equivalent to about 3 times the size of an Olympic swimming pool. At the opposite end of the spectrum, representing a larger home range size, there is the adult red morwong, who can grow up to be 26 inches long, and they have demonstrated a mean home range size of up to 39,170 feet squared, or the equivalent to 70% of the length of a football field, an American football field. So yeah, it's pretty big, definitely a lot larger than a lot of the captive spaces will provide. So similarly to that, similar to the really large home range sizes we see in the wild, we also see species that have migration distances that are pretty large. So species of really mobile carp have been documented to make frequent upstream and downstream movements of more than 62 miles per month, really great distances. So just to put that into context and compare that to the captive environment of fish, many of the largest aquarium tanks contain just up to 180 gallons of water, which is the equivalent of about to, which can be compared to an average bathtub, which holds about 42 gallons of water, which is really, really, really restrictive in terms of movement for these fish. So as a result, many fish develop abnormal behaviors and swimming patterns in captivity to cope with these extreme spatial conditions. So the welfare substandards in zoos that became prevalent through our research, as of 2023, no animal care manual exists for any species on the AZA website. So therefore, these facilities have 0 minimum standard requirements for things like enclosure size, environmental substrates or features, social groupings, diet, or even enrichment provision for fish. So there's no requirements that any of these things need to be up to a certain standard or even present. The only fish-specific guidelines we found included those pertaining to water quality, sunlight exposure, and tanks having critical life support mechanisms, which I want to note have failed in the past, which has resulted in the death of dozens of animals at one time. So the only category of aquatic animals specifically outlined in the AZA standards include cetaceans, which are whales, dolphins, and porpoises. So I want to go a bit more into depth for touch tanks, because these are arguably one of the most ethically wrong things that zoos and aquariums do involving fish. So we know that numerous environmental factors can affect fish welfare, and yet there are no standards by which touch tanks are required to be operated. So some consistent psychological behaviors and physical impairments have been observed to be directly associated with animals in touch tanks, and therefore likely indicative of poor welfare and health in these captive environments. So a couple examples of those behaviors would be stingrays participating in surface breaking behavior, which is when they lift the upper front of their body above the surface of the water repeatedly. And that can indicate a stereotypy or abnormal repetitive behavior associated with a really high stress level. And another example of that would be tail wagging in dogfish, where they attempt to escape the exhibit by walking on their tails and jumping out of the tank. We also need to mention zoonoses, or diseases that could be transferred from animals to humans, which pose a major health concern to both the humans and animals involved. So the big ones would be salmonella, fish to humans, and tuberculosis, which can be transferred from humans to fish. So the unsustainability practices in zoos that became very prevalent to us. So even though the vast majority of AZA accredited facilities have aquatic animals in their care, more than 76%, things like the import, captive breeding practice, transfer, and enclosure standards of fish in zoos are still largely unregulated or just non-existent. And then, like most but not all animals kept in zoos, the majority of marine fish are wild caught. So their very presence in zoos has negative impact on conservation efforts in the wild. So just to summarize legislation in the United States, fish are not protected by law other than exceptions made for fish in aquaculture and also those listed on the Endangered Species Act. Fish are really not even considered to fall under the category of animals in many circumstances. And the USDA and APHIS, which work together to enforce the Animal Welfare Act, don't require individuals to register for an exhibitor's license to own fish, even large-scale operations like zoos. So therefore, as of this year, no federal legislation exists in the US at all that protects fish kept in private possession in terms of animal cruelty, neglect, or abuse. So at these facilities, there are never inspections. There are no standards to which they should uphold. It's just largely very loosely happening all over the country. So our recommendations moving forward to protect fish would be to halt the wild capture of fish in zoos and aquariums, to phase out touch tanks from aquariums, as they don't contribute to any genuine conservation efforts, and they directly negatively impact the welfare of the humans and animals involved. And then to also include fish in the definition of animals in both state and federal animal cruelty legislation, so that we can better protect their health and welfare. So that concludes my presentation. Thank you so much for listening. And I will go ahead and turn it over to Jack.
Hey, Jack, can you hear us okay?
Yeah, that's great.
There we go. Thank you. Fantastic.
Can you see the presentation? Yeah. Can you see the presentation? Is that okay?
It's not coming up on my screen, Jack, right now.
Okay, 1 second. There we go. Should have fixed it. Is that on there?
That's there.
Excellent. Great. Okay. So as you can probably tell through the title, Glorious Fish, I'm a fan of fish. And this will be a celebration of fish in general, but it will also try to illustrate why we should care for fish, some of the complexity, some of the diversity, why I personally have come to love certain species and why I do the work that I do. And yeah, I hope that this is just a broad overview. I'm going to massively struggle to keep to the 10 minutes because there's too much to say about fish, and I'll do my best to cut me off if I start to ramble. So I'm going to be talking about wonderful group of fish, diadromous species, meaning that they live in both freshwater and marine, spawning in one, so maybe spawning in the marine environment and moving into freshwater to grow, live and thrive and develop, or the other way around. I'm going to be particularly talking about a couple of individual species, which I'm going to focus in their sort of freshwater phase. This is mainly because I'm a freshwater ecologist. I work with these species in a freshwater environment, and that makes me slightly biased. And I also think that they do, when I say they, I mean freshwater fish, do often get overlooked for some of the more maybe charismatic species living in beautiful tropical areas. As well as this, there is an accessibility to freshwater species. When I mean accessibility, what I mean is a lot of people would have access to their local river, their lake, their loch, if they're in Scotland, which is where I do most of my work. And this means that the interactions or the potential for interactions is quite high. But the reason we don't maybe interact with fish as much as we should do, or we potentially could, is just because we need to delve into their world. We need to break the surface of the water to immerse ourselves within an environment which is completely alien to us, which does not really promote our survival, and yet we see these species which are thriving and incredible to watch in these environments. So when we think of the diversity of fishes, of fish species, the majority of people, I think, across the world would envision something like this picture here, a beautiful coral reef with a vast range of species in both size and colour. And this is definitely a true interpretation, a diverse, wonderful, rich ecosystem. But as much so, I see the diversity of fish or fishes represented in something like this picture. This is actually a beaver dam, and this is on the River Teith in Scotland. And this is a wonderful salmon river. It's very, very productive. It's incredibly diverse, and I think our appreciation of fish needs to broaden. And these two pictures here represent that perfectly. I think, you know, we find incredibly complex and diverse range of species in freshwater environments and in marine environments. And there is incredible species in each of these. And this really needs to be brought back to the individuals. Now, I'll talk about maybe some of these individuals and why I personally find them so interesting. So, some of the overlooked species, this is me in my natural habitat, looking bedraggled as usual, but this is where I'm definitely the most happiest. And when I think of some of the species that we have, and when I'm talking about we now in the UK, but across the world, our freshwater environments hold some true gems. This is one which I'm going to talk about. This picture on the left-hand side, this is a deceased sparling, as it is known in Scotland, Osmerus apellanus. This is a European smelt. There are smelt species across other areas of the world. And this individual on the left-hand side who has actually died, this was due to the result of a predator attack over the spawning of this particular species. And this species spawns in great numbers, very much like the salmon. They move in mass into our river systems and spawn on the heads of the tide. And they push their way up into these high reaches of rivers and spawn there. And they're incredibly weak swimmers. So these things have to fight so hard to get to where they want to go to. But they're so focused on spawning and so focused on breeding that they will often beach themselves, or predators will walk into the river very leisurely and pick them out very much at ease. They're so focused on spawning and reproducing. And this species is gorgeous. It might not look like a species that is particularly good looking in some of the I guess normal ways in which we would measure this, you know, real bright colors and a rather extravagant fins or any aspect. It's just a really truly gorgeous fish. It has an olive green back. It has a translucent stomach. It's it's an odd thing to look at once it's out of water and you can see it closely, but in the water it might be just misrepresented as just a generic fish. One amazing and incredible trait of this species is that it actually smells of cucumber. And I found this species spawning on this 1 or 2 days that it comes into our river systems in usually February by standing downwind of this species, downwind of the spawning location, and I could smell cucumber. Absolutely amazing. One of the unfortunate realities is that this is one of the last populations in Scotland. It only occurs in 3 rivers now across all of Scotland. And this is usually due to a whole myriad of different reasons, but one of the greatest drivers is pollution and fresh water that isn't clean enough for them to spawn in. I don't know if you can see this, hopefully the video is playing, but you can just see this small shoal of sparling swimming together in the river, and just absolutely gorgeous. And you can still smell that cucumber on the wind, even when you're not downstream of the whole group of them. But it's just a truly incredible moment in my life. For all the people that know me, eels is something that is Anguilla anguilla. This is the European eel. The American eel, Anguilla rostrata, spawns in a very similar way. I'm going to talk about the spawning and reproductive cycle of the eel here. So it starts in the Sargasso Sea, and this is for both American and European species. The eggs floating on the current will hatch out after a couple of days, and this larval form will then float in, it looks sort of like a translucent willow leaf floating on the current, and it can take years to sometimes reach the continental shelf of either Europe or of America, depending on the species. Once this species reaches our coastlines, it is a translucent, it's eel shaped, but it's translucent, and you can see through this middle picture, this is sort of what you'd envision, only a tiny bit of pigmentation, but it's known as a glass eel then. As it moves into our freshwater areas, our rivers, our streams, and pushing up into the headwaters, it's known as an elver. This is just a pigmented eel, and as it grows through this phase, it's referred to as a yellow eel, growing for sometimes up to decades before it reaches a certain point in its life where it has enough reserves to start to change into the next and final phase, which is a silver eel. And it starts to move its way back down our rivers, our streams, from where it's been surviving and growing and gaining resources over these years. And it starts outwards seaward migration. But the body changes. It has a silver, a truly metallic silver stomach, has a jet black back. Its eyes have grown in size. On the right-hand side, you can see this picture where the eyes are huge on this bottom eel. They grow even larger as it starts to develop and sexually mature even further. Its fins change shape. The whole body structure changes to focus its resources on sexual reproduction rather than just growing and developing and gaining resources. And unfortunately, this species, again, is under threat. This is, again, a huge myriad of different issues facing it. But to a large degree, it's loss of habitat fragmentation through river barriers, such as dams and weirs and sluice gates and hydro schemes. And in particular with hydro schemes, they get chopped to pieces as they pass through the turbines. And there are 101 of different things impacting this species. There are many, many more I could speak of, all with, unfortunately, quite a negative downward trajectory of for this population, which is a shame. Some figures just to chuck at you, 1% of the Earth is covered by fresh water, that's just 1% of the surface of our Earth, yet 51% of all known fish species are represented within this environment, within our freshwater zones. 30% of all freshwater species, freshwater fish species, are threatened with extinction. And we lost 80 of these wonderful animals, or wonderful species, in just 2020 alone. 35% of our wetlands disappeared in the last 50 years. But this was 35% of what we had left 50 years ago. Think of what we would have had 100 years ago, 200 years ago, 300 years ago. Our understanding of the baseline needs to change to truly preserve these species. This is just a wonderful report by a conglomerate of wonderful organizations focusing on some of the forgotten fish species. And I recommend this as a definite read if people wanting to sort of learn more. The threats we're facing, I know I'm running low on time definitely now, but river barriers, meaning fragmentation of habitats, meaning that fish can't push up into different areas of the river and exploit the resources they need to survive. Habitat loss, so the draining of wetlands, the removal of it, and increased agricultural pressures, which also attributes to pollution. Fishing pressures, both legal and illegal. There is a huge illegal trade in European eel, a multi-billion-pound black market. Invasive species don't do anything for these wonderful native species either, and there are many, many more. But as many issues as there are, there's always many answers. Barrier removal, we just take and destroy these dams and these fragmentation, this fragmentation of habitat. We improve this by adding fish passes, which needs to be properly designed and properly monitored. We replant the riparian zone, which is the zones that surround our rivers, the trees which allow dappled shading and lower the temperature of our rivers, allowing multiple species to spawn in rivers which are cold enough to allow this to happen. And it adds vital nutrients in our headwaters. Habitat restoration and rewilding projects, all of these are majorly important. I'm slightly over time, so yes, I'm very much looking forward to answering any questions that you have. But please do get in touch, and Forgotten Fish Project is where I've done lots of my work with the eels, and my work at the Forgotten Fish, at the Forth Rivers Trust and at the University of Hull is continuing. So please do get in touch if you have any questions. And I will pass over to David Neal.
Thanks very much, Jack, and thanks very much to Born Free for giving me the opportunity to talk to you, and thanks everybody for being here to listen. I'm an educator more so than a behavioural researcher, but I'm going to talk about some of the work which has been done to demonstrate fish sentience and their social complexity and their cognitive abilities. And I hope through this presentation, and I'll do the researchers that have carried out much of this work justice. So just firstly, just to put it into some context with numbers, then you can see the numbers that we're talking about, and this is why the topic of fish sentience is so critically important. The numbers that we're talking about are astronomical. So for commercial fishing alone is somewhere in between 1 to 3 trillion individuals per year, which are being taken from the seas and the rivers. And for things like aquaculture, we're talking about over 100 billion individuals which are being farmed for our consumption. So fish sentience is an incredibly important topic. Now, it's still a debate within much of the scientific literature, and there are still a number of individuals that will continue to say that fish do not possess the prerequisite neural architecture for phenomenal consciousness, which essentially means that they do not feel pain. This was an article which was written just a few years ago by Professor Brian Key from the University of Queensland. Fortunately, there are also many others which will say the opposite, such as Professor Colin Brown from Macquarie University, a behavioural ecologist, who suggests through this article, again, around a similar time, that extensive evidence of fish behavioural and cognitive sophistication exists and pain perception, and therefore suggests that best practice would be to lend fish the same level of protection as any other vertebrate species. Now, I'm pleased to say I'm in the UK, and within the UK law, then fish are protected within the animal welfare law. Well, as we know, fish are recognised as sentient individuals in the UK, also within the European Union, but unfortunately still do not receive that same level of protection as many other species, and that's something which a number of organisations are now working to try to improve. So if we look briefly at fish sentience, well, fish have those same basic body plan as mammals. They have a backbone, they have this wide suite of senses, they have a peripheral nervous system, which is then governed by the brain. And fish have what we call a pallium. So it serves very similar functions to the neocortex, which has been recognized within mammals, and the paleocortex within birds. And they have these forebrain structures, or their forebrain contains these brain structures that are able to perform very similar functions to those which we already associate with pain and the experiencing stress and fear within many other vertebrate species. Research has demonstrated the presence of polymodal nociceptors. In this case, then brown trout were found to actually have 58 different receptors located just on the face and the head. And these were responding to mechanical and thermal and chemical stimuli. So these were sending messages. Once these stimuli reached these parts of the body, they were sending messages to the brain. Now we know that just because something has a nociception, it doesn't exactly demonstrate that it can actually feel and that it actually has sentience. But what we've seen through a whole host now of behavioral research is that the researchers have demonstrated these behavioral changes exist within individuals when they are given these negative stimuli. So in this case, again, these were fish which had an injection of acetic acid into the lips, and they instantly changed their normal behavior and started to exhibit an abnormal behavior. And in addition to that, would rub their lips along the floor of their tank, which again would suggest that they're trying to deal with this pain in some ways, similar ways that we would do ourselves. And other evidence suggests that this negative reaction is dramatically reduced when a painkiller is applied, or when they have an access to a tank which has painkiller within it. So then normal behavior can be resumed not long after this painkiller is given to them. Fish will also do something called avoidance learning, so they can learn to avoid a negative stimulus, which is likely to give them or cause them to experience any sort of stress and fear. So in behavioral experiments here, a fish which is in a 2-chamber tank, and a negative stimuli such as a net is plunged into the tank. If just before that net is plunged in, then a light source is flashed on, fish can quickly learn that when they see that light source, they can move to a second area of the chamber so that they avoid that negative stimuli, so they can experience this avoidance learning. Again, if they are experiencing some form of negative stimuli, such as the pain which has been administered, similar to those experiments where the acetic acid was injected into them, then this will impair their ability and their awareness of their environment and their ability to actually perform that avoidance behavior. And similarly, again, if they are given the painkiller, then that normal avoidance behavior and that awareness will quickly return. So there's a huge amount of evidence from the neurobiology of animals to suggest that fishes are sentient animals, and I'm very pleased to say that the majority of now the scientific community is accepting as fish as sentient animals, and we're beginning to see fish sentience become into legislation around the world. Fish also possess very complex social and cognitive abilities as well. And I want to just sort of finish off by talking a little bit about some of those social complexity and cognitive abilities of fish. As we know, many fish species are incredibly social, schooling, spending a huge amount of time with each other. But this is not just random association. So individual fish are forming complex relationships with other individual fish within their shoals. So they're not just randomly spending time with other fish. They will actively choose to be with individuals, and tracking individuals shows that certain individuals will stay together. They like to feed together. They feel much more protected when they are with those individuals that they have an association with. We also see evidence of both intra and interspecific cooperation within fish. So rabbit fish, for example, pairs of rabbit fish will go off on foraging forays, and one individual will be foraging and the other individual will act as a lookout, and those roles will reverse. And so the other, once one of them has been foraging for a while, they'll reverse, and that one will become the lookout. And if they do see a predator approaching, then they will inform the other individual that there's a predator coming, and hopefully they'll both be able to survive. But we also see interspecies cooperation as well. So, example of the coral grouper will cooperate with the moray eel on the coral reefs to hunt for prey. Now, these are two different species, and the coral grouper will actually do a sort of a dance to actually advertise that it wants to go out on one of these hunting expeditions. The moray eel understands this communication, and if it accepts, then they will both go out on a hunting expedition. Now, the coral grouper is likely to be able to take fish from the open water, whereas the moray eel is more likely to go into the crevices and be able to take fish inside the crevices, inside the corals. And so, working together, the grouper will force fish into those crevices, the eels will force fish out of the crevices. These individuals are much more successful in their hunting if they cooperate with each other. We also see evidence of altruistic tendencies within certain species. And so the South American cichlid species have shown to choose pro-social choices to actually provide food for other individuals, even when there's no benefit to them themselves. And they're more likely to provide food to other individuals that they've had a positive experience with themselves, rather than providing food randomly to other individuals. So if they've had this positive experience, they recognize that other individual as an individual that they've had a shared experience with, they're more likely to choose to provide that individual with food. Fish communicate. There's an extensive amount of communication, and we're learning more and more about this each and every day at the moment. They communicate with intention, so they communicate specific information to other individuals, and they communicate the intention of what they want those individuals to do with that information. A lot of this is done through vocalizations. We're learning a huge amount now about this vast array of vocalizations that fish are delivering to each other within their habitats. Some of this is actually done regionally. So individuals like the codfish are being shown now that certain populations of codfish have very specific vocalizations, passing information to each other about their environment, about potential predators and potential threats within their environment. And actually, these sounds are slightly different from other populations. So they're almost developing these regional accents. Fish will also communicate, as well as communicating vocally, also communicate through gestures, as being shown in the manta rays, which have these sort of small fins just near to their faces, and they will use these fins to be able to give information to other individuals within their social group about what they plan to do. They learn socially, so an individual can observe another individual. In this case, a naive individual is likely to observe a more experienced individual. They understand the objectives of what they're trying to carry out. They understand the intentions of what they're carrying out. This has been observed in things like archerfish. Archerfish shoot water out of the river and to try to hit a terrestrial target like an insect to get it to fall into the water for them to eat. Young archerfish are likely to learn this skill by observation, by watching more experienced individuals carry out this behavior, and then they can learn to do it themselves. It's also something which has been seen in commercial fisheries as well. Actually, salmon hatcheries, if young salmon are given the opportunity to spend time with more experienced salmon within that commercial environment, then they learn how to find food and how to forage within that commercial environment. And this is actually increasing the success rate of those salmon. So again, learning socially about how to find food within that particular environment, particularly important for them. There is a whole range of examples of maternal and paternal responsibilities which fish undertake. This is often quite surprising. We don't see fish often as being maternal or paternal in the way that they behave. Fish like the sticklebacks and the damselfish will protect the eggs, but also often protect the young fry as well when they've hatched, and try to keep them protecting them from predation. Sticklebacks will aerate the eggs so to ensure that they keep oxygenated before they hatch. We have examples of play behavior, particularly within captive individuals which have no particular predatory threat, are in an environment where most of their needs are being met, will engage in object play, so actually choosing to carry out behaviors which are enriching to them. We also have observations of deceptive behaviors within fish. So an example is the Atlantic mollyfish. Atlantic mollies, the males will pursue a female And normally what will happen is one male will start to pursue the most desirable female, and other males will come in and maybe try to displace that male. So the individuals have been seen to start to pursue a less desirable female, to deceive the other males, to chase that less desirable female. And when they get displaced, they then are free to try to chase after the more desirable female themselves. So deceiving the fish into thinking that individual was the one that they were originally after. When I was young, then obviously there was, and still to some degree now, there is this idea that fish have terrible memories. The goldfish 3-second memory couldn't be further from the truth. There is so much research now showing long-term memory ability within fish. Examples of the frill-free goby fish, which lives within the tidal zones. They can spatially learn their environment, and they create their own mind map by swimming. When the tide is in, they'll swim over these rock pools. They learn where all these different rock pools are, and then when the tide goes out and they're in one of those rock pools, it means they can move between rock pools to find resources, but also they can jump between rock pools if there's a predator within their own rock pool. So creating this mind map, which they can then use to benefit themselves. Fish which have been taught certain problem-solving skills and then not being tested have been shown to be able to continue to go back and to be able to carry out those problem-solving skills up to a year after they've originally learned them. So they have this long-term memory ability. We know examples of individual recognition, facial recognition, fish being able to recognize another individual from their facial features. We also know from the archer fish that they actually can recognize people. So we have human facial recognition with individual archer fish being able to recognize different human individuals through behavioral experiments. And we also have examples of things like fairness and examples of moral behavior existing within fish. An example being the cleaner wrasse, which are cleaner fish which will live on the coral reefs, and a client fish will come, and these individuals, usually acting in pairs, often a male and a female, will spend their time cleaning the individual, so taking all the parasites and the dead skin. And these individuals have their own social rules to say one of the individuals may want to take a bite out of the fish, which is much more tastier and much more nutritious, but is less likely to when they're operating in pairs, because the client fish is likely to swim away because of the pain that it might experience through such a bite. If an individual does do that, then in some cases, the other individual may pursue that client fish as it swims away and effectively apologize for what has just happened. The literature describes this as giving this client fish a back rub. So they will be more attentive to that client fish, give it lots of attention to try to coax it back to this cleaning station, where they can continue to provide it with this service. And if the client fish swims away, then in some cases the male fish, which is likely to be the one which is trying to do this apologetic behavior, will actually reprimand the female because they've both lost out. So that social contract has been broken. These cleaner wrasse have also shown that they are self-aware. They can identify themselves in a mirror, so they understand that they exist as an individual within their environment, separate to others. And also we have huge numbers of examples now of problem-solving abilities for fish within their natural environment. And most recently, there's been quite a lot of work done on the use of tools, the planning that fish go through to bring certain objects from a certain environment back to a home environment where they can use a tool. So the tusk fish in particular would go out collecting clams and then bringing them back to a certain rock and anvil where they can then use that to open up those fish. So I've raced through a whole host of things there, but fish are incredibly complex individuals. They're complex from a point of view of sentience, but also from a social complexity and a cognitive complexity as well. So thank you very much for the opportunity to discuss a little bit more about fish.
That was all amazing. Thank you so much to all of our three panelists. Fish are not my area of expertise, and I've learned a huge amount on this in this presentation. I think there's some notes that I made, my takeaways, particularly Dave's last slide, just thinking about anybody who thinks that fish are not sentient or not intelligent. You could have been describing our sanctuary and the monkeys who live there in all of those things. For those of you who don't know, we operate a large primate sanctuary in South Texas, and we have 200 or so monkeys there. And just all of those things happen. All of those things happen at a primate sanctuary, and we consider, primates and fish to be so far apart usually. I think the one thing that we don't tend to see with primates is apologizing and fairness. So fish are probably better at primates than that. Jack's point about, trees lining freshwater areas being really important for spawning, that's another thing that I'd never really thought about, because I think when I think about fish conservation and preservation, you think about water quality, but that just kind of opened up kind of my thinking about what else is needed to protect fish and their wider habitats, not just literally the water they live in. And then of course Devon's observations about how fish will work for something, that even if it's difficult for them. I think you've just shared such interesting information today that everyone can learn from. So if Devon and Jack, you want to come back on camera, we've got some questions. We've still got about 6 minutes. We started a little bit late, so I'm going to try and get a question to each of you, if that's okay. So starting with, I'm going to finish with you, Devon, because yours is more of a kind of call to action that I want to ask you. So I'm going to go back to Jack right now. Can you talk a little bit about, so the 1% of the world's water is fresh water, and yet 51% of species diversity is there. Can you talk a little bit about that? Why is that?
Well, yeah, in terms of why that is, a lot of it is due to the isolation through, I guess if you think of species as being isolated in an area, and their ability to diversify and access different niche habitats, for example, or niche resources, this stimulates a great deal of diversion and evolution within even the same species, to separate them out so that there is more exploitation of different resources within that environment. So this isolation sometimes can be something that promotes the number of species within a body of water, which is somewhat relatively simple at the start. And once different resources start to grow, develop, and aren't exploited, then there is, there's something which is driving species to separate, whether that starts off as behavioral changes, which means that maybe a species goes to a more benthic environment, so they go to the bottom of a lake, and the species is naturally surface or mid-column feeding fish. And that slowly drives evolution and slowly drives the change and separation of a species. That can be one thing which drives it, and means that this species splits into multiple ones within a single habitat. But also, there's just the way that we see freshwater is we don't see it as something which is particularly complex. And there is so much diversity just within the flow. Just the dynamics of how water moves through this environment means that you don't have the same environment or the same exact environment in every single natural system. You start to see more uniform and I guess simple habitats when humans start to get involved, when we straighten our rivers, when we canalize sections, when we start to form things into what we see as necessary for our progression. That's when you see these habitats being less diverse, and it supports fewer species, and as a result, ecosystems start to break and crumble, and you get a very, very few organisms being able to survive in what used to be a wonderfully diverse wetland or wonderfully diverse stream, river, lake, loch, whatever it is. So that's some of the reasons.
Yeah. I also have one other quick question for you, Jack, which you may or may not know the answer to, which has been asked by our audience. So is the threat of artificial light at night something that ichthyologists are looking at? And I hope I pronounced ichthyologist correctly.
You did. Well, that's how I pronounce it, which is probably wrong, actually. So yes, it definitely is. It's a huge area of research, especially within migratory species. So my true love, my true passion, the eel, is something which has been researched and has been looked into, sort of this effect of artificial light, and does it impact their movement through a system. And a lot of the studies found that it doesn't always prevent the movement of a fish from point A to point B, but sometimes it will slow them down. And it does this because they're a nocturnal species moving in the night, being most active at night. And the presence of artificial light obviously changes their perception of that environment, and maybe their willingness to move themselves into an area where predation could be quite easy, just through being able to being more visible. And there's signs that it does significantly affect some species and it doesn't affect others, but there's a wide range of spectrums within this. And what we do know is when habitats aren't lit with artificial light or aren't messed around with, then these natural orders are balanced, and we find that these systems function in the ways that they should. So whether or not it has a huge or a small impact, sometimes it can be a death by 1,000 cuts type scenario, where if it has a very small impact, but that impact is still significant when paired with every other pressure that these wonderful species are under constantly, it could potentially have that tipping of the scale effect.
That's really interesting. Thanks, Jack. I'm gonna squeeze in 2 more questions, which might run us over for a couple of minutes. But Dave, why do you think people care less about fish than other animals, despite our strong associations with them?
Yeah, I think it's a good question, and it's something which, you know, we all kind of ponder. I think you know, fish are living in an alien environment. Jack really sort of, you know, highlighted that to us. It's to us in this terrestrial environment, then the freshwater, the marine environment is alien to us. So that we just don't get that exposure to them, which I think is something that certainly needs to be addressed through our sort of educational work, particularly in schools, of trying to sort of bring in that aspect of bringing children closer to that environment, whether that be physically or whether that just be through virtual reality or whatever, is something which would really help. The lack of cute cuddliness, you know, we're all there. Look at the pictures behind me. You know, one of my major projects is elephants. I'm not saying we shouldn't be doing stuff with elephants, but it's so much easier to be able to get people to empathize with things like elephants. Animals Asia do, you know, a big project on bears. Fish are just not so cute and cuddly when you look at them in comparison to many of the other species. It challenges our way of life, right? You know, so many people that I know are recreational fishermen. You know, so fish is such a huge part of people's diets, particularly in certain parts of the world. So this information about fish experiencing pain, but also this social complexity and their cognitive abilities, cognitive complexity, it really does challenge us as individuals and it challenges everything that we're about. And so I suppose those are all the reasons, but those are all the things that we need to try and break down. And one of the reasons why I'm so keen on talking about this, not even though I'm not an expert, a behavioral research expert or anything like that, is really to also say, you know, it's time for the animal organizations. You know, I'm really pleased that Born Free are doing this, because, you know, we've all dropped the ball on this for decades. You know, all of us, you know, are responsible. I've been involved in animal protection for over 20 years, and it's only in the last few years I've started talking about fish, you know, as part of that debate. You know, I've spent many years talking about some of the other terrestrial farmed animals, but I've dropped the ball on it. Animal protection organizations have dropped the ball, and I'm really pleased to see now that, you know, we're beginning to pick up on that, because we all have a responsibility, I think, to try to get this issue into the public consciousness. So hopefully, you know, we can do that through, you know, this kind of work, and it's great to see the likes of Born Free, you know, being active in that debate. So I hope that helps.
Yeah, absolutely. Thank you. And that, Dave, leads right on to my question for Devon, is what can the average person do to help this issue?
Yeah, there's a few things. I think number one would be to stop visiting places that have these animals held captive for entertainment. So places like zoos and aquariums that do have so many of these fish species that we've mentioned today, that do have all of these amazing abilities, cognitively, socially, all of those things. So I think that would be an important first step. And if you came into this conversation maybe supporting fish being in captive situations, hopefully we've, you know, changed your mind by now. But I think the second thing I would recommend is that we have a petition on our website, bornfreeusa.org, in our action center, calling on Association of Zoos and Aquarium Facilities to stop having touch tanks. So essentially to ban the practice of touch tanks in aquariums at the AZA member facilities. So if you want to go there and add your name to our petition and support that effort, that would help us out a lot in, you know, our message to zoos and aquariums and how we feel about fish in captivity, but also in touch tanks specifically. And then last, I would say, share our resources, share the reports done by Born Free USA, like the report I summarized today, Oceans Away from Home, and then also the work of the organizations that David and Jack are a part of as well. I think everything is really beneficial that we've discussed today, and just making sure as many people know this as possible would really help with those efforts.
Absolutely. Thank you so much. Thank you for everyone for staying on for those extra few minutes. Thank you so much to our panelists. This has been fascinating. Some of you are asking for more information. We will be sending out an email tomorrow to everybody who participated with the recording and the contact details and information for all of our panelists. So you'll be able to get in touch with us or Dave or Jack to ask any follow-up questions. Please do go support everyone's work. So Jack's work at the Fourth Rivers Trust, Dave's work at Animals Asia, who do incredible work, not just with fish, but as he says, with bears and all sorts of other animals as well. And of course, Born Free. If you're not already signed up to our e-alerts and our newsletter, please do, so that you'll be the first to hear about any events coming up. But thank you all for your time, especially to our panelists. And I hope everyone found it as enjoyable as I did. Thanks, everyone. Bye-bye.
Thanks very much. Thanks, Liz.